Imagine your critical application grinding to a halt, the user's furious, and your server screaming for help, all because of one tiny, overlooked detail in your database. This isn't a hypothetical nightmare. It's a very real, very common disaster. If you work with databases, develop applications, or manage systems, understanding this critical vulnerability can save you from catastrophic outages, lost revenue, and endless debugging headaches. This isn't just theory, it's about protecting your digital infrastructure. By the end of this video, you'll not only understand how a missing index can devastate a database, but also gain the practical knowledge to prevent it, detect it, and fix it. The database as a library, a search analogy. Think of a database as an enormous, meticulously organized library. Every piece of information, every row of data, is like a book on a shelf. We need to find a specific book, say all users named John Doe. How do you do it? Without an index, your database has to perform a full table scan. It literally goes through every single book, page by page, until it finds all the John Does. For a small library, that's fine. But what if your library has billions of books? This is where indexes come in. Imagine a library's card catalog or a book's index at the back. Instead of reading every page, you look up John Doe, get the exact shelf and page number, and go straight to it. This is the fundamental power of indexing. What is a database index, really? The B-tree deep dive. At its core, a database index is a data structure, most commonly a B-tree or B-plus tree, that stores a sorted copy of specific columns from your table. Each entry in the index points directly to the location of the full row of data. When you query for data using an index column, the database doesn't scan the entire table. Instead, it traverses the B-tree, quickly narrowing down the search space until it finds the exact data pointer. This is exponentially faster, especially for large datasets. There are different types: clustered indexes, which physically sort the data rows themselves, and non-clustered indexes, which are separate structures pointing back to the data. Understanding this distinction is key to optimal performance. The silent killer, when indexes go missing. So what happens when these crucial indexes are missing? Let's say you have an e-commerce platform with millions of orders. A customer tries to view their order history, filtered by customer_ID. Without an index on customer_ID, your database must scan every single order. This isn't just a slight delay, it's a crippling performance hit. Imagine hundreds or thousands of users trying to do this simultaneously. Each request becomes a full table scan, hogging CPU, memory, and I/O resources. Users experience slow loading times, timeouts, and frustration. In a competitive market, even a few seconds of delay can lead to significant user abandonment. Over 50% of users will abandon a mobile site if pages take longer than 3 seconds to load. You've seen the silent threat, but how does a missing index escalate from slow performance to a full-blown database meltdown? The answer lies in a chain reaction of resource exhaustion that can bring your entire system to its knees. Let's dive into the core mechanisms of a database meltdown. The meltdown: how a missing index crushes your server. When multiple unindexed queries run concurrently, the CPU starts working overtime, processing millions of rows unnecessarily. This CPU spike is often the first symptom you'll see in your monitoring dashboards. Next, I/O operations skyrocket. Reading entire tables from disk instead of small index pages puts immense pressure on your storage subsystem. This creates an I/O bottleneck, slowing down every other operation on the server, even those with indexes. Memory also becomes a casualty. The database engine tries to cache frequently accessed data, but when it's constantly scanning huge tables, the cache becomes ineffective. It's like trying to keep a library clean while someone is pulling every book off the shelves. Detecting the invisible problem: tools and techniques. So, how do you find these hidden culprits before they cause a meltdown? The first and most powerful tool is the explain analyze command in SQL. This shows you the query execution plan, revealing if a full table scan is happening. Beyond individual queries, performance monitoring tools like Prometheus, Grafana, or cloud-native solutions, AWS CloudWatch, Azure Monitor, are essential. Look for spikes in CPU, I/O wait times, and high database connection counts during periods of slow performance. Many modern database systems also offer built-in missing index advisors. SQL Server has dynamic management views, DMVs. PostgreSQL has PG__ statements, and MySQL offers performance schema. These can explicitly suggest indexes that would improve query performance. The fix: creating and optimizing indexes. Once you've identified a missing index, creating one is straightforward. It's typically a simple create index SQL command on the column or columns used in your where clauses, join conditions, or order by clauses. But don't just add indexes blindly. Over-indexing can also hurt performance, especially for write operations, insert, update, delete, because every index needs to be updated. Aim for high selectivity. Columns with many unique values are ideal candidates. Consider composite indexes for queries involving multiple columns. For example, customer_ID, order_date might be more effective than 2 separate indexes if you frequently query by both. Always test index changes in a staging environment first. Let's recap. Missing indexes force full table scans, drastically slowing down queries. This leads to CPU, I/O, and memory exhaustion, potentially crashing your database. Tools like explain and performance monitors are crucial for detection. Strategic index creation and optimization can prevent these disasters. The key takeaways: always analyze your query execution plans to identify full table scans. Monitor your database's resource usage regularly for early warning signs. Create indexes on frequently queried columns, especially in where, join, and order by clauses. Be mindful of over-indexing. Balance read performance with write overhead. If you found this valuable, hit subscribe and the notification bell. Drop a comment with your experience or your own database disaster stories.